Hello, algebra. Hey, look, it's Gerald, the stick man. On the graph, it's a graph walker. He's gonna help us out. So here's your do now. How many answers will there be to this absolute value equation? Absolute value of x minus 2 equals -3. So if we translate that absolute value statement, basically means the distance. Absolute value always means distance. So the distance between those two numbers inside the symbol, x and 2, is -3 spaces. And we cannot have a negative distance. So we're familiar with, on an absolute value equation, we go to a number line and you can move, little graph walker, either to the left or to the right. But either way, that is going to give us a positive measurement of distance. So if a little sick person goes to the right, that's a positive number on the ruler and on the number line. And if we spin around and go the other direction, it's going to move towards the negative side of the number line, but the distance is still measured as a positive number, still positive. And so there's no such thing as a negative distance, only positive distance, regardless of which direction we go, which means this equation is trying to tell us that the distance needs to equal -3, and we can't do that. It's not possible. There is no mathematical thing equivalent to a negative distance. So there are no solutions to this equation. You can't have negative distance. All right, well, so that basically sums up everything we're going to look at in this whole lesson, but we better explain some more. Solving absolute value equations is a topic again today. We'll be looking at solving absolute value equations still. It's the last piece to solving absolute value equations today. So we've seen these steps before, and we've been focusing on step 1, getting that absolute value isolated on the one side of the equal sign. And today we're going to look at a way where we can shortcut some of those steps if there are extraneous solutions, which is step 5. We've seen that step. We've not actually done step 5 yet. And so today is where we get to do step 5. It actually shows up. We're going to check for extraneous solutions. So there's a way we shortcut straight from step 1. We bypass 2, 3, and 4. We can go straight to step 5, but we have to recognize what that is. So check for extraneous solutions basically means look for fake answers. And the way that we do that, you can see over here in blue, is anytime that absolute value expression, whatever's inside of it, but you get that absolute value expression by itself, if that equals a negative number, that's not possible. That means it's a negative distance, and that will mean that there are no solutions, or it's telling us those are fake answers. And so that's what we're trying to find out. Are these answers fake? Well, yeah. If it says it's a negative distance, then that's a fake answer. So what does that actually look like? Okay, so here's the first example. Absolute value of 4x minus 2, and then plus 9 equals 6. So we're going to continue to do the same process we have been doing the last couple of days. We need to find that absolute value first. We need to find that equal sign second. I'm going to draw a line straight down from the equal sign as the division of my problem into two parts. There's a left side and a right side, and where the equal sign is that balance point. So anything on the same side of that equal sign where the absolute value is, but which is outside the lines, I need to get rid of it. That's what isolate the absolute value means. And so this 9 right here, that's going to have to go away. So at first glance, I mean, I know I have some work to do, but what we sometimes think is, you're like, okay, it's got an absolute value equation, it equals positive 6. I'm in the clear. And that might be making too quick of a decision. We might be jumping to an incorrect conclusion. So what we need to do is get that absolute value isolated. So I'm going to subtract the 9 from both sides of my equal sign. And then get absolute value of 4x minus 2. Equal sign comes down, 6 minus 9, and that is where I run into a problem, because that is -3. Because once we get that absolute value isolated, when we find out that it equals a negative number in this case, if the absolute value is a negative number, well, that's representing a negative, the negative number is a negative distance, and that is not possible. There's no such thing as a negative distance. And so this is going to be an extraneous solution. We could continue to solve. We would get extraneous solutions. And negative distance is not possible. No solutions. Okay, so if we were to continue with the other steps in the process, we would get some solutions. X equals this, X equals that. And those solutions are extraneous, meaning they don't actually make the original equation work. We can look at that in a little bit. But the main thing we're looking for is get that absolute value isolated. If it equals a negative number, there is no solution. Right? So the appropriate response as a mathematician when you have a problem like this is you just say there is no solution, or you could say it's not possible. And for us, since we're doing our assignments in WAMAP, we are going to write DNE. An abbreviation does not exist. Essentially means the same thing as no solution, just different words, and we get to abbreviate. So it's actually shorter. DNE does not exist because absolute value has got the negative answer there. All right, next example, negative absolute value is 6x plus 3 minus 1 equals negative 22. And so based on what we just saw on the last problem, we may be tempted to say, oh, look, it's equals a negative number. I think that means there's no solution. That means you were paying attention. That's awesome. Nice job. But we're going to not jump the gun here. We don't want to jump to any conclusions. Maybe it means there's no solution, but we need to make sure first. So possibly this is no solution. I'm going to put a big question mark on that. Let's find out. So I got the equal sign, and we got the absolute value. Okay, so there are some things on the same side of the equal sign where the absolute value is, but which are outside the line. So we're going to need to get rid of those. So there's this green negative sign. There's this blue and negative 1. And let's go like this. So the order of operations for solving is described by our acronym SADMEG. And subtraction and addition comes first. So that means I need to deal with this blue part here. I'm going to add 1 to both sides. These are going to cancel. So the negative sign comes down. Really, that's like a negative 1 in there being multiplied by the absolute value, 6x plus 3. So if it would be helpful to you, you can totally fill in that invisible 1. The negative sign just means negative 1 times. And sometimes we just don't write it down. Sometimes it's helpful to see it. So, all right, let's see. The other side of the equal sign, so I had negative 22, I'm adding 1. If I had a negative number and then I add something to it, that's going to make it less negative or a smaller negative number. So negative 21. And then we're going to divide by negative 1 to get rid of that leading coefficient, the negative 1 that's outside the absolute value symbol. I'm going to divide by negative 1 on the other side of the equal sign as well. I'm going to write it with different symbols, so we got to continue to practice seeing that in different notations. They're both mean division. Just there's different ways to write it. So that is going to cancel. And then let's see, the absolute value of 6x plus 3, that comes down, the equal sign comes down, and on the other side of the equal sign, get a negative number divided by another negative number, which gives me a positive answer. I get positive 21. So our original assumption that, hey, since that equals negative 22, which we circled up there in magenta highlighter, it was a good thing to notice, but it turns out it did not stay as a negative distance once we got rid of all the other stuff. Actually, it's a positive distance. It's positive 21, and that means we can go ahead and do the rest of this problem. We need to go ahead and do the rest of this problem. Those solutions are going to be actual solutions. And so let's get some more space. Let's continue. So now that I have the absolute value symbol isolated, I can trade that in to get my two versions. 6x plus 3 equals positive 21. And over here, 6x plus 3 equals negative 21. So let's go ahead and do the green one first and get some more space. All right, and I got my Whoops, I got my number line down there waiting. We'll graph when we get finished here. So I'm going to subtract 3. Shoop. 6x equals 18. I'm going to divide by 6. Divide by 6. And then we get x. Whoops. Let's do it in green. X equals 3. Let's do the blue one now. So I got to subtract 3. Got to subtract 3. Shoop. 6x equals negative 24. Divide by 6. Whoops. Divide by 6. Divide by 6. And that gives me x equals negative 4. So there are our two solutions, x equals 3 or x equals negative 4. I'm going to put both of them onto the graph. Dot at 3, another dot at negative 4. And those are both actual solutions. We need to report them both.